This is SpaceTime Series 25, Episode 66. Coming up on SpaceTime, NASA's Mars probe MAVEN back in service following a major glitch, unraveling the mysteries of brown dwarfs, and 3 new crew members board China's space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's MAVEN spacecraft is finally back in operation after defaulting into an emergency safety mode in February. Mission managers eventually traced the problem to its Inertial Measurement Units, which are responsible for navigation. Technicians were able to bypass the problem by developing a new program allowing the spacecraft to operate using stellar navigation. MAVEN's principal investigator, Shannon Curry from the University of California, Berkeley, says the fix should allow the orbiter to continue studying the Martian atmosphere and acting as a telecommunications relay satellite right through until the end of this decade. NASA's MAVEN, or Mars Atmosphere Volatile Evolution mission, was launched back in November 2013 and entered into orbit around the red planet in September 2014. Its primary mission is to explore the planet's upper atmosphere, its ionosphere, and interactions with the sun and the solar wind to explore the loss of Martian atmosphere to space. Understanding atmospheric loss gives scientists an insight into the history of Mars's atmosphere and climate, liquid water, and planetary habitability. Mission managers lost contact with the spacecraft on February the 22nd after it performed a routine scheduled power cycle of IMU-1, which is used to determine the spacecraft's altitude in space by measuring its rate of rotation. MAVEN has 2 identical IMUs aboard. Once contact was re-established, telemetry showed the spacecraft was unable to determine its altitude from either IMU. In response, MAVEN performed a computer reboot, but still couldn't determine its orientation. And that triggered the activation of a backup computer, which allowed MAVEN to get accurate readings from IMU-2. It then switched into a pre-programmed safe mode, where it ceased all planned activities, including both scientific and relay operations. In this state, it awaited further instructions from mission managers. Now, luckily, earlier issues with the IMU-1 and the fact that the IMU-2 was already nearing the end of its lifespan had resulted in mission managers developing a new stellar navigation program for MAVEN, which they were planning to upload anyway in October this year. The failure forced the spacecraft's team at Lockheed Martin to accelerate their work on the new software and upload the code as soon as possible. The new patch was ready and uploaded in mid-April. And following a series of tests, the new stellar mode was successfully activated, allowing MAVEN to return to normal operations. This is SpaceTime. Still to come, unraveling the mystery of brown dwarfs, and 3 new crew members board China's space station. All that and more still to come on SpaceTime. Astronomers have discovered 5 brown dwarfs, objects which fill the gap between the largest planets and the smallest stars. The 5, reported in the journal Astronomy and Astrophysics, will provide new clues about how these rare objects are formed and evolved. While some brown dwarfs may have been born as such, others are thought to start their lives as spectrotype M red dwarf stars, which lose enough mass during their evolution to cease core nuclear fusion, the process which makes stars shine. That turns them from red dwarfs into brown dwarfs. Current estimates suggest that brown dwarfs fit into a category between the largest planets, which have about 13 times the mass of Jupiter, and the smallest spectrotype M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or to put that another way, about 0.08 solar masses. However, Astronomers still don't know exactly where the mass limits of brown dwarfs lie, limits which allow them to be distinguished from low-mass stars, especially since their composition is often very similar to that of low-mass stars. Like Jupiter and other gas giants, stars are mainly made up of hydrogen and helium. But unlike gas giants, stars are so massive and their gravitational force is so strong that hydrogen atoms in their core fuses into helium, releasing huge amounts of energy and light. Brown dwarfs, on the other hand, are not massive enough to fuse hydrogen in their core. Therefore, they can't produce the enormous amounts of energy and light that we see in stars. Instead, brown dwarfs fuse relatively small stores of a heavier atomic version of hydrogen called deuterium. The study's lead author, Nolan Greaves from the University of Geneva, says these limits may vary depending on the chemical composition of the brown dwarf, or the way it formed, or its initial radius. To get a better idea of exactly what these mysterious objects are, astronomers need to study them in detail. That means getting as many examples as possible. But it turns out brown dwarfs are actually quite rare. Despite all their efforts, so far astronomers have actually only characterized around 30 brown dwarfs. Now that compares to billions of stars and thousands of planets. The 5 newly discovered brown dwarfs were identified by NASA's Transiting Exoplanet Survey satellite, TESS. These so-called TESS objects of interest have been catalogued as TOI 148, TOI 587, TOI 681, TOI 746, and TOI 1213. Each of these brown dwarfs orbits a host star, with periods ranging between 5 and 27 Earth days. They have radii between 0.81 and 1.66 times that of Jupiter, and are between 77 and 98 times more massive. And this places them right on the borderline between brown dwarfs and red dwarf stars. These 5 new objects, therefore, contain valuable information. Each new discovery reveals additional clues about the nature of brown dwarfs, and it provides science with a better understanding of how they form and why they're so rare. One of the clues which scientists have found to show up in these objects is the relationship between their size and their age. Brown dwarfs are supposed to shrink over time as they burn up their deuterium reserves and cool down. But the authors found that the 2 oldest objects, TOI 148 and TOI 746, are so close to their limit that they really could easily be very low-mass stars. And the authors are still unsure whether they really are brown dwarfs. Brown dwarfs are one of the features in the current issue of Australian Sky and Telescope magazine. With the details, we're joined by the magazine's editor, Jonathan Alley.
Today, Stuart, to take a look at these special kind of stars that have been known for a long time as brown dwarfs. There's a sort of a long history of calling small stars out there, because you've got supergiant stars and you've got giant stars, you've got sort of normal-sized stars, and then small ones, they've called them dwarfs for a long, long time. And these brown dwarfs, they've often been called failed stars, because they weren't big enough in terms of mass, which sort of equates to size, but mass, weren't big enough to have enough mass to squash their cores, the middle bits, so tightly that nuclear reactions took hold, and bingo, you've got a radiating star. They just weren't massive enough to do that. We now know that there are some reactions that can occur inside and cause a bit of heat, but nothing like a real proper star. So they're small and they're not as massive as a normal sort of star, not big enough to radiate lots of light and heat and that sort of thing. But the thing is that astronomers have now found planets out there in space that are around about the same mass as some brown dwarfs. And they've also found some brown dwarfs that are around the same mass as planets, raising the question, how do you tell them apart for these particular categories? So the dividing line between some planets and some stars of this kind has become blurred. And so have the ideas about how they formed and everything. So brown dwarfs, like any other kind of star, have been thought to form within big clouds of gas. That's where you get stars forming. They're called star-forming regions, these big clouds of gas. Planets, though, they're thought to form within the swirling mass of gas and dust that collects around a young star as it is forming and when it gets formed and first gets lit up, if you like. That's the planets form out of this. They call it a disk swirling around. An accretion
Protoplanetary
swirling
disk.
around this. Yeah, and it's sort of a planetary accretion disk swirling around a newborn star. So that's what they think that planets are formed, whereas brown dwarf stars are formed actually out of big clouds of gas. Now it looks like some planets orbiting far out from their stars may actually have formed like brown dwarfs from within collapsing gas clouds. And meanwhile, some free-floating brown dwarfs may have formed like planets, initially within a swirling disk around a star, and then have got flung out of their star system and then to float through space forever on their own. So in the magazine, we take a deep look into these so-called failed stars and the competing hypotheses about how they came about. It's really quite interesting. And I remember, must be back in the 80s, I guess, brown dwarf stars became the target of a bit of a hunt, I suppose. They'd been proposed, but no one had ever seen one or detected one or found one. And so there was a bit of a rush on between astronomers in different parts of the world to be the first to absolutely confirm that they'd found a brown dwarf. And I do remember a couple of astronomers here were made some claims that they had. I don't think that really got anywhere. But it wasn't long before, with better telescopes and things, that they were able to detect it. Now, brown dwarfs, because they aren't proper stars that radiate a lot of intense heat and light, are actually hard to spot because they're cool. They're small as things go in space, and they don't give off a lot of energy. The energy they do give off is in the heat part of the spectrum. So what has just been launched, James Webb Space Telescope,
Yes.
which is optimized for looking for
infrared.
cool things, infrared cool things out there in space, things that give off a bit of heat, but not much. They're very cool. So brown dwarfs, I imagine, are going to be popping up left and right once the James Webb Space Telescope starts having a look around.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come. 3 new crew members board China's space station. And later in the science report, scientists develop a living human-like skin for robots. If you think that sounds creepy, wait till you hear how it sweats. All that and more still to come on SpaceTime. Three Chinese taikonauts have arrived safely aboard Beijing's new Tiangong space station for what will be a 6-month mission to complete construction of the orbiting outpost. The trio blasted off in their Shenzhou 14 capsule aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center in northwestern China's Gobi Desert. They'll replace the Shenzhou 13 crew who returned to Earth in April after 183 days on station. The Tiangong, which means Heavenly Palace, is expected to become fully operational by the end of this year, with 2 more science modules being added to the main body. Last month, the Long March 7 rocket blasted off from the Wenchang Satellite Launch Center in Heian Province, carrying the Tianzhou 4 cargo ship loaded with 6 tons of fuel and supplies, which successfully docked to the space station 7 hours later. It's been a busy time for China's space program, with Beijing launching an ever-growing flotilla of spy satellites designed to keep an eye on the Communist government's growing list of adversaries as it continues what Beijing says is its build-up for war. In late April, China launched 5 Xiaoling-1 Guofang reconnaissance satellites into orbit using a Long March 11 rocket fired from a floating launch platform in the East China Sea. Beijing claims the new spacecraft will be used to provide commercial remote sensing data services for sectors including land resource survey, urban planning, and disaster monitoring. In reality, they're spy satellites designed to provide high-level surveillance capabilities. Another pair of Earth observation satellites, the Saoui-Going 101 and 102, were launched a few days later aboard a Long March 2C rocket from Jiuquan. Once again, Beijing claims they're designed to provide commercial remote sensing data services for industries including surveying and mapping, as well as environmental protection, urban security, and digital rural development. Since 2016, Beijing has launched more than 188 Earth observation, surveillance, or reconnaissance satellites designed to provide near-continuous high-resolution and electronic monitoring of areas of interest to China. The last month has also seen Beijing launch a new atmospheric environmental monitoring satellite. That was flown aboard a Long March 4C rocket from the Tian Satellite Launch Center in northern China's Shaanxi province. The spacecraft's equipped with 5 scientific payloads designed to monitor air pollution, including a new laser-based carbon dioxide detector, as well as instruments to measure aerosols and other particulate matter. Meanwhile, a Long March 2C rocket has successfully placed 9 Geely 01 commercial satellites into orbit, launching from Jiuquan Satellite Launch Center in southwestern China's Sichuan province. This constellation will be used to research and validate a range of technologies, focusing primarily on car connectivity and communication systems such as navigation, mobile phones, and interfaces between the car's manufacturer and its onboard black box. A week earlier, China launched a Long March 2C rocket from Jiuquan, carrying what Beijing describes as 3 low-orbit communication test satellites. No other details were given. But it's not all been smooth sailing for Beijing over the last month or so. Just 2 weeks ago, a new Chinese commercial launch vehicle suffered a major failure. Initial reports suggest that the 4th SQX-1 mission had a smooth launch and first stage solid rocket engine burn, but for some reason the 2nd stage solid rocket engine failed to ignite. An investigation into the cause of the incident is now underway. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.